Continuing 1.4, algebraic limits. You have one correction to make in your notes. This should be flipped around in your notes. Okay, so we're going to get tricky with it today and use those trig limits that you put on your list for the last video. Now, last time we saw if it was sine of x over x, the limit as x approaches 0 was 1. Well, in fact, it doesn't just have to be x, it could be any function. Okay, same thing with the cosine limit. So the limit as x approaches 0, sine of 5x over 5x is still 1. The limit of this function is still 0. And in this one, this one's a little bit tricky, but notice this isn't 0 anymore, it's 7. So it's moved to the right. 7. Okay, and this function is also moved to the right 7. So it preserves that trig limit, so the answer here is just 1. Okay, now we're going to make it a little bit more exciting. So we're going to combine our properties of limits that we've already learned and this new trig idea. Let's see if we can figure it out. Now, we can't just take this part of the fraction and ignore the rest. Okay, so but we can break it down using properties of fractions. So if the limit as x approaches 0, I could write this as x over x. Well, that's just 1. 1 plus sine of x over x. Now the limit of 1 as x approaches 0 is 1. Limit of sine of x over x as x approaches 0 is 1. So 1 plus 1 is 2. Okay, this time we didn't have any properties with tangent, so we're going to have to use the quotient property of tangent. We're going to make sine over cosine. Oops. No, we could just plug in 0 immediately because we get 0 over 0. That's a problem. All right. So this doesn't really help us. Look, multiply the top and the bottom by cosine. We get x over sine of x times cosine of x. Okay, now plug in 0. For this, we get 1. For cosine of 0, we get 1. So our limit is 1. Okay, this one, we definitely don't have anything with secant, but secant is 1 over cosine. So I'm going to write that up here. 1 over cosine theta minus 1 over theta times, 1 over cosine. Oh, let's just erase the whole thing then. Over theta times 1 over cosine. If we multiply the top and the bottom by cosine, check out what happens. Cosine times cosine. Alright, I'm trying here. I really am. Yep, sometimes it makes you feel better just to scribble it out. And then you erase it because it's calculus and you have a nice eraser. Alright, maybe purple. Limit as theta approaches 0. Cosine times cosine, that's 1. Minus 1 times cosine, cosine. Cosine times 1 over cosine, 1. We have theta. Wow, that looks just like our identity, so it's 0. And we'll try a couple of ones and we can find this. Let's see, this is a neat one. I'm going to just make that orange. I'm going to break it apart. Sine of 5x over x times 1 over cosine of 2x. Alright, so can I just plug in 0 directly? That was that sine of 5x over x. Now, if only there was a 5 there. But I can't just divide by 5. I could also have to multiply by 5. I guess I could write it anywhere else. I'll put it over here. So now our limit as x approaches 0, we get 4 times 1 times 1 times 5. So our limit in this case is 20. It's kind of neat how that worked out. I'm going to erase this. I'm going to get some space for the next problem. Let's see. tangent, I'm going to write it as sine over cosine. I'm going to write it kind of broken down. If my computer wants to cooperate, if it doesn't, then I'm just going to keep trying and trying and trying. So that's what you do with calculus. Oh, no, it's close. It's close. I got one more time. All right. Come on. We can do it. Good. We got it. All right. I'm ready for this. Sine over cosine. And then I have this sine. No, we can't just plug in 0 because of this last term here. Okay, that makes it the problem because then we get 0 in the denominator. We can't do that. So here's what we can do. I do know that if I put this over, I can do that. I can do that as long as I put my x in, and let's leave my 3 up top. All right, so I did that. That's fine. There's nothing wrong with this. You're going to put a 1 just to make it look nice. Now I need a 4 here, but then I'm going to have to put a 4 here. Okay, so all I'm doing is multiplying, dividing by clever forms of 1. So sine of 3x over 3x, that's just 1. Again, we have 1. Here we have 1, and then we have 3/4. Very nice. Very nice. And then look, tangent of 3x over sine of 4x gives us 3 over 4. All right, again, I'm going to clear this out so we can work on the next one. All right, so cotangent, that's cosine over sine, so I'm going to write that out. I'm just going to have a let's try that. Okay, and then I have cosecant, so that's 1 over sine, or just reciprocal, so I'll have sine 25x. I put my special numbers in. Nothing wrong with cosine of 11x. I can put 0 in that without making a problem. Here I'm going to need an 11x. So I'm going to stick my x over, and I'm going to stick the 11 on here. Now I need a 25, and then I need a 25. So I get 1, 25 over 11. 25 over 11. Not so bad, right? We get a chance to practice with many of these. In fact, I think what I would like you to do, yeah, of course, this one for the whisk. This one's exciting. Be careful how you break this down, though. We'll do the last two, and then we'll finish with the a little bit more. Actually, we can do these in class if you want. They're pretty similar. Okay, but I do want you to do that for the whisk. And here for our video, change the page. If you just memorize all of this, it'll be really easy. Okay, and if not, you can always break it apart, just like we just did. And our last example, the last way of doing these problems is general cleverness. So you have to be pretty clever to be in calculus. And you get to show that here. All right, so for example, we could break this apart, right? I can make this limit as x approaches 0. 5x times x over 1 minus cosine x. It's pretty clever, right? Because I know that's one of my special trig identities. So then it's going to be 0 times 1, which is 0. Okay, trigonometric substitution in this case, I don't think it's going to work. So you have to be clever. And you think, oh, wait, I could probably factor out a 3 there. In the bottom, you have to be really clever. What is that factoring to? Well, conveniently enough, it factors into this. square root of something squared is just that same thing. So I'm going to get rid of this. These cancel out because we don't need to worry about anything at 5, just on the other side. So we get 3. And you get really good at this. It might seem like magic what I'm doing. Okay, but it gets really, really easy the more you practice. All right, so we'll do a couple more. Let's see. What could we do here? So there's a lot of things. We could probably find some trig identities, do a couple things. I'm going to make my denominator cosine. And again, I can see things happening that you can't yet because I have a lot more experience with these problems than you do, but you'll get there if you try. All right, so all I did was change the denominator to cosine, and I'm also going to factor out a negative and rewrite this so I know where I'm going. Just trust me. Whoops. Okay, in the top, if I combine it, I get cosine x minus sine of x over cosine of x. Okay, in the bottom, I could bring that to the top, and I get -1 times cosine x minus sine x. Minus sine x. Guess what? All right, either way, yeah, it's canceling out. So now I have the limit as x approaches pi over 4 of -1 over cosine of x. You could think about it as secant of x, okay? Or you could think about it as cosine. Plug in pi over 4, and you get -1 over square root of 2 over 2. Rationalize, or at least flip it over so it's not a complex fraction, and you get negative radical 2. Again, pretty neat problem. It takes a little insight. So the last two involve, this one involves so you have to know how to expand the sine of x plus h. And I'm not going to take the time to do it right now, but this is one that you guys choose to. You just have to tell me you want to do it. And this one just involves a bit of factoring. And once you factor, it's a pretty easy problem. So if you want to do that in class, just let me know. All right, have a good day.